Recording in progress.
Cool. Okay. So let's take a look at number one. You guys see how I broke that apart? There's a times in between. So you put a log, and you put a 3 in front of log 2. Let's take a look at B. See how that's broken apart? There's a minus in between. And you have to put the 5 in front of the whole thing because the whole thing's risen to the 5 power. What was that? Sorry, John? So homework. I'm just going over the homework. Yeah. For C, again, you got to subtract, but the 6 only goes in front of log Y. For D, 1/3 goes in front of the whole thing. And you have to break apart as addition, log X plus log Y plus log Z. I'll put this in Schoology as well. I still am slow updating homeworks. And remember, our test is Friday. And I think, look at my calendar. I think I'm available Thursday night. I don't think I booked myself anything. Yes, Thursday night, I am free. Hold on. Yeah.
Oh, yeah.
Yeah. Is 8 o'clock good or 7 o'clock, 9 o'clock? What's good for you guys? What do you guys prefer? It's 9 a little too late? 8 to 9? 8 p.m.? Because I know some people have sports, some people are not back home till 7. I'll say a little later. No, well, I get pretty tired too. Okay. Well, let's do 8 o'clock on Thursday, the 6th. Okay. We'll do that. All right. Okay. So we'll do a Zoom session. Okay, for number 2, I'm not asking these questions directly. But these skills you need to know, like that's log of 3/8. The 6 goes in front, rolls to the back. So if U6 V6 or UV raised to 6, and then ln x over y4. All's good there for 2 ABC. Yeah, cool. All right. No problems there. All right. The next step, okay, some people ask about the equations. So this would be about having taught this class last year. I could use my materials. Remember, if you have exactly one log on each side, drop the logs, set the expressions equal to each other. That should be x equals 3. If you have one log, then you have to undo it. So you have to divide the -2 and then raise it, do 5 to the -1 power, it becomes 1/5, and divide by 7, you get 1/35. But remember, if you have just one log, your goal is to get x by itself. Anything that's connected to the log has to be undone. How's that -2 connected to that log? By what operations?
Okay.
What's opposite multiplication? Division. So you have to do the opposite. You got to divide by -2. And always be trying to go in reverse PEMDAS order when you're undoing equation solve for x. Because the log is like an exponent in a way. So I take care of that -2 first. Actually, if you think about it, let me get this here. If you think about PEMDAS, right? If you think of PEMDAS, we have a parentheses. The E is like a log, just to know. The exponent is like a log. And M is multiplication. So obviously, if you're plugging something for x, you got to do 7 times that number, do the log, and then do -2. But what's the opposite of it? The multiplication part. So you get rid of that first, then get rid of the log next, then get rid of the 7 afterwards. So you go in the reverse order when you're solving equations, right? That's what we do. But for part C, you have to combine the 2 logs first. Likewise with part D. Use your log properties to do that. So expect, these are a little too easy, I feel. The log second degree in delta math is precisely what to expect in the test for log equations. So really do delta math. Yeah, but anyway, get those. Any answers? I'm sorry, any questions on those at all? No, we're okay. Okay, cool. Good. All right. Let's keep moving. Oh, there was a graphing problem. I'll have to do that a little later. For 6-1-13, you have that. That should be pretty straightforward. So that makes sense. You have to do logs. Let me clear the screen here. Okay. Oh, very important. For part B, please don't do this on the test because if I give you something like this, don't show 18 in here. Divide 18 first. Because think about it. you think about time balance, right? You have exponent and you have multiplication. If you're plugging a number for x to evaluate it, what comes first in the order of operations? The exponent and multiplication. Exponent, right? You would not want to distribute that 18. Do not do that. Divide the 18, get rid of it, then rewrite the log, and then of course solve for the inside of 2x minus 1. So that's 6, 1, 13. I'll do the graphic problem in a moment. For the word problem, so some people are getting a little kind of fluster with this one. They thought like, oh, don't I have to use like the finance formula? Well, this doesn't involve finance. This is just y equals a times b to the x power, right? And so if you think about it, your a value is 23,500. Your b is your rate, but you're dropping by 20%, so the rate's actually 0.8. And then they ask you what's the cost of the car for 4 years? Great, plug in 4. But then how many years would it take for the car to be worth 6 grand? So set the equation equal to 6 grand and solve for x as an exponent, meaning you have to use logs. And then part E, you just go back in time. Actually, that is no, yeah, I solve for A. So I let y be 20,500 solve for it. Or you could let A be 23,500 and let the exponent be negative 2.7. So you could have done this also. Y equals 23,500 times 0.8 raised to negative 2.7. That could work also. You still would have got the same thing. So the car is about 43 grand when you bought it brand new. So, okay, so that's okay. All right. And then the last one, 6140. I'm not going to ask this on the test. But just make sure you know how to undo it, like 6 root or raise both sides to 1 over 3.8 for part B. For part D, raise both sides to the 1 over 3 power or cube root it. For E, divide by 4 first. Do not distribute that. Then raise both sides to the 1 over 12.5 power. And that's how you get that one. Oh, there's also a part C. I missed that one. And that's the 4th root of 1 over 100, which is 0.316. Okay. Oh, there's the log, the graphing problem. Let me do that here. For the graphing problem, what do we start with? Start with this, right? How do you rewrite that? What does that become? X equals. No, I'm doing this problem right here. Sorry. I'm doing the graphic problem right below. So that'd be x equals 2 to what power? 2 to y, good. Make a table. What are good values of plugging for y when you have the parent function? What do you usually use? Good, excellent. So you get 1/2, 1, and 2. Now, what are the transformations? If you have a -3 on the inside and a +1 on the outside, how am I going to change the x values? That becomes what? You have to add 3. How about the y values? How do they change? Yes or no? If it's a +1, how do I change y values? Go up. Good, thank you. Go up 1, yes. So you plot the points. It looks like this. So you have a vertical asymptote here. So this is why delta mass, I think, is going to be really good for you guys because you really need that drill and kill. Oh. And if you're wrong, I'll tell you wrong and just keep at it until you get it. Domains X is larger than 3. Non-inclusive. Range is all real. Asymptotes X equals 3. I'm not going to ask for intercepts. Don't worry about that. That is like a test problem. That's a very good test problem. The graphic. The graphic log will look. Yep. Yep. It'll look just like that.
Why is it like, what is the significance of it being 1 plus instead of like there being a coefficient in front of the log?
No, well, the one plus is a vertical shift up one.
Oh.
If you had a number of
Yeah.
fronts, vertical
Wait, is this
stretch.
the same as just
Plus-
equals log 2 x minus 3 plus 1?
Exactly.
Oh,
Right.
okay.
It's the same thing. It's plus one off to the side. Yeah. Off to the right. That's how we usually see it. It's the same thing. Yeah. It's no different. Yeah, it's a little scary. Yeah. Yeah. Okay. I get it. Okay, so we're good on that. All right. Okay, so just to kind of close the loop, because we've seen most of the stuff that's on a test, right? But there's one last thing I need to talk about before we finish off the unit. And then the rest of the class, you guys could work on homework, or you could do the review stuff. That's fine. Or you can do Delta Math. Delta Math's good too. Everyone has access to it now. So let's do another word problem. Okay. So I have to say we're incredibly more focused without Alexander here.
Yes.
No, I think it's just when one of you guys are missing. It's anyway. No, or maybe you guys have food coming from lunch. I don't know. Okay, let's keep moving here. All right, number one. Um, ooh, that's a good one. Okay, suppose your friend wants to borrow $100. Your friend promises to give you an extra $100 when they return the money in a year. So okay, so say for example, I lend Nathan $100, right? And then Nathan said, I'm gonna give you back $200 by the end of the year. So cool. I get my $100 back and I make $100. Of course, I have to wait a year to get it, but what is that interest rate though? That's what, so that's what we want to solve for. So if you think about it, I mean, we could do this right now if you want, but it should be pretty obvious. How much return did I get on my money? Double. So it'd be 100%. So you don't really have to do any math to figure that. I mean, that's kind of an easy situation, but if I lend $100 and I get back $200 and it took 1 year, then what's B gonna equal? 2. If B equals 2, that's gonna be doubling, which means my money went up by 100%. So it's 100% return. But I'm not gonna ask that. That's kind of easy. But what if I compound it monthly? Now that formula looks like this, which is not that much different. Y equals A times B to the X power. It's not that much different. I know it looks a little messy with all the N's and T's and P's and A's. It's really the same thing. What's your initial amount? How much money do you want to finish after a year? You want $200, right? So it's like Y and A, right? It's not the same thing. Okay, the rate has to be divided by what though? By 12. And how many years are we doing this? For 1 year. So I have to solve for R. And then we're going to compound daily. And then we're going to compound every second. And then we're going to see what's happening after a while. I'm going to use a calculator to work this out. I'm going to kind of save time for us here. But let's set up part C and part D. Let's set them up and I'll actually use my calculator to solve these. How many days in a year? So the R with 365. By the way, these are not test problems. This is just more of a demonstration. Just, these are not test problems. And then, fortunately, the number of seconds given to us, I don't have to compute that because I do not have that memorized. But just take the number of days and multiply by 24 hours, 60 minutes, 60 seconds. Yikes, that is crazy. That's a lot of numbers there. A lot of seconds. And that's raised to the, oh boy. Okay, let me pull up a calculator. Give me a sec here. Goodness, we're good. Okay, cool. All right, let's look at part B. How do I solve for R? What would be the first thing I have to do? So I'll do 200 Divide by 100. Okay, so 2 equals all that junk. And actually, let me write that in green so it kind of stands out. So 2 equals all that junk. Okay, how do I get rid of that 12 exponent? What do I do to both sides? Not square root, but close. What kind of root do I do? The 12th root, exactly. So I have to raise that to the 1/12th power. So I raise that to the 1/12th power. Yeah, 100%. Because when you raise a power to a power, you multiply the exponents, and anything times the reciprocal becomes 1. That's why it gets rid of it. So 1.0595. Okay, then I should subtract 1 and then multiply by 12. Okay, well, still a pretty high rate, but it drops quite drastically. So it becomes a 0.713 or 0.1714 or 7.4%. So that's how I go about solving part B. So let's do same thing for the other two. I'm actually gonna use a handheld in this point to save time. So divide by 100, raise it to a particular power, see what you get. So 2 raised to the 1/365 power. And then subtract 1, multiply by 365. We get 69.4%. And let's do it again. So 2 raised to the, oh, but goodness, 1/31536,000. Subtract 1 times 365. Oh, divide by 365 makes no sense. Times 31536,000. Okay, so I get 69.3%. Okay, so it seems to converge after a while. Um, so, and I think that deals with, hold on a sec. Okay, does the answer part 2 surprise you? No. We expect R to converge to a particular number as n gets larger. Okay, so what's happening there? It's a little tricky. But what's happening there is that we wind up getting this formula, which is compounding continuously. And so if I were to work this out, A equals for 200. And by the way, that number, in case you're curious, um, equals that or 0.693. And ln stands for natural log. I'm going to talk about that in a moment. But you wind up getting a convergence as n gets larger. So if I were to work this out, times e, I'll talk about e as in a moment. I think did we talk about e last first unit? We did, yeah. Okay, it's been a while. So 2 equals e to the r. So how do I isolate r? I have to do log base e of 2, which is 0.693, and a bunch of other weird numbers. Or 69.3%. So, and again, log base e is what we call natural log. So I'm going to go over that in just a moment. But again, this is not so much a test problem. It's more just understanding what e is. That e is some sort of number that converges because n gets larger. So as a result of that convergence. So like if every wake in second money's being added to your account, ultimately, fine. I mean, that's great that money's coming in, but it's just coming at very small fractions. So we're going to talk about E in just a moment. But that's what's going on with compound continuous. It's when you're compounding money all the time. And so there's some sort of convergence that occurs there. And just so you know, in the graphing calculator, you guys see where it says ln? Okay, what is that really? So if you have e raised to some power equals y, you can rewrite the equation like this, which same as ln. Same exact thing. So ln y equals x. Let's go through some of these problems here, and then after I'm done, you guys can just work. These are not test problems, but I should just talk about it just so you guys know what's happening. Let me do these over here. So E is roughly this. It's like 2.718. E comes from this. As n approaches infinity. So that's what E is. It's just some numbers. It's called Euler's number. Euler Leonhard was, well, sorry, Leonhard Euler, I should know this, my math history. Just a mathematician, French mathematician from a long time ago. It's called Euler's number. Yeah. And we'll talk about ln when we get to number 7. But for this one here, if you have E3 times E4, that's just E7. Don't overthink it. It's just use the properties of exponents. So with that said, what do you guys think is true for number 4? No, for number 4. Yep. Okay, well, number 5. Good. It'll be 8 E9X. Again, these are not test problems, just so you guys know that E is just, you treat it the same as you would any variable or exponent or a base. If you have raised to -4, that should go on the bottom. So it's 1/16 E8. That's 1/3 E5X. That's going to be E4 minus 2X, I think. You just add them up. Okay, let me stop there. I want to make sure you guys are following what I'm doing. You guys just write some random numbers. You guys do half with number 3. E3, E4. E is just like a number. It's like any number like 2 or 3 or 4 or 5 or 6. This doesn't really matter. That's E to the 7th power. And then you see I got e to the 4 power from number 4. Yeah, -2 plus 6. For 5, you distribute, so 2 cubed is 8, of course, and then e 3x to the 3 right to 9x. For 6, you have to flip it, so it goes 2 to the -4 power, so it's 1/16. And e -2 to raise to the -4 is e8. For 7, you gotta flip it, goes 1 over all that junk. That's all. For 8, you can combine x and -x, make it -2x, add 4 and get that. For 9. What happens if you square root 9? What do you get? 3. And what do you think the power would be next to e6? What was that? Well, you're square rooting. So what's the exponent for square roots? Bless you. If you replace the square with an exponent, what does that become? 1 over 2, right? And then how do you combine the 6 and 1/2? What's 6 times half?
3.
3. 3. So it's 3e3. So be careful about that. And then lastly, that's 5e to the 2x plus 3. So again, these are not test problems, but just good to know how your properties of exponents. And even though e is not a variable, it's a number, you could treat it like a variable when you're doing the properties of exponents. Again, e is just a number, it's 2.718. Comes from the notion that 1 plus 1 over n raised to the n powers n approaches infinity, converges. And we saw that convergence kind of happen with that word problem we just did with the finance. Okay. ln, just so you know, let me erase this stuff here. Just so you know, natural log of x is the same thing as saying this. It's the same exact thing. Okay. So that's the same thing. So ln means log base e. It's the same thing. So if I see this here, I mean, whenever these are the same, what can I assume when those are the same? They just cancel, right? So you get 5. So when you see ln, think of it like this. Log base e of e to -1 power. Because 1 over e is e to -1 power. What does that become? When these are the same, what can we assume again? Just becomes what? So they cancel, you get -1. Let me move this around. Oh, my goodness. Okay, for C, that would be log base E. And what would I put inside the parentheses? What's root E as an exponent? E to what power, guys? Square root? Not 2. Not 1. What's square root, guys? You guys know that 1, 1/2. So that's 1/2. Okay. So enough with the E. Let's talk about other stuff. Okay. Now DEF. This is very important. Because I'm gonna ask this on our test. So going back to the outline again for the test. Shoot. Oh, here we go. Let me clear the screen for a moment. Okay. On the outline for the test. You have graph and log equations, graph and exponential equations, evaluate log expressions. Okay. I do have some practice problems in Delta Math on this. And I'll show you where it is in Delta Math. It's going to look like this here. If you click on condensing numerical logarithms, it's kind of like that a little bit. Like, for example, how would I do this one here? What would I write? What's 2 to the power 2? What's 8 over 4? 2. There you go. So submit. If I try another one. So that'd be log base B of 1. Yep. Cool. Okay. So let's look at these problems now. In the notes. D, F are going to be just like the evaluating logs on part 1 of the test. Okay, that's gonna be just like test problems. So D, E, F, both, all three. Sorry, all three. So let's look at D, E, F, and then I'm all done for today. You guys can work on homework. Okay. So John and Reggie, I need you guys to focus. So how would I combine this? What would that become? Which is good. Okay, how many times do I multiply? So then I don't know what this is. I'll call it X. How many times do I multiply 4 to get to 64? You guys think? 3. That's it. Yeah, that's the answer. Okay, let's look at the other two. Okay, do you see that 2 there? Where should that 2 go? Move it to the back. So you have log base 5 of 10 squared minus log base 5 of 4. What's 10 squared? Good. Okay, what can I do next? Let's divide it. Let's try to divide by 4. 25. So 25 equals 5 to the x power. What would x equal?
2.
Perfect. Good. Okay. And then lastly for this one, log base 3 of 162 over 2. What's half of 162? What do you guys think? 81. So 81 equals 3 to the x power. Don't worry. Just use your fingers. 3, 9. What's 9 times 3?
27.
What do you think 27 times 3 is?
81.
Yeah, it's 4. Yeah. It's not that bad. So expect the non-calc problems, the evaluating logs look like this, to look like DEF. LN will probably be involved somewhere else. I think probably with the inverse log problems. I think we're gonna have it with that. So just make sure you know LN's log base E. You'll have that chance to work through that. So homework will be pretty simple. We've got about another 20 minutes. Guys, cross stuff off your worksheets. There's certain problems I don't want you guys doing and not worrying about. So cross this off. Cross this off. Cross off 149 and 150. Because I'm not going to ask it on the test. On the homework that follows in the packet. Cross them off. You guys did great with it on the test. I don't need to reassess it.
49, 50.
149, 150.
So like when 151, 150, 158.
I do want you doing those problems for sure. Actually, cross off 158. I'm not going to ask that.
Oh, yeah.
I'll post the school G. Definitely going to do 151 and 152.
Wait, 151, like what would that be? Like what type of problem?
That would be solving an exponential equation or solving a log equation for D. Like would be in part 2. Definitely do the graphs. So homework's really light, actually. You guys can totally knock this out. So 151, 152, and graphs number 1 to 4. That's your homework. After that, if you want to get a head start and review, you can. You have the review packet. If you want to go Delta Math, pull up your laptop, you can do that. If you got other stuff to do, you need to take a nap, whatever you no, whatever you gotta do, it's all good. So but yeah, you can knock the homework out, get that done, start the review for the test. And then I want to do some Delta Math on Wednesday, and I'll see if I have a Jeopardy game we can pull up. I'll see if I have one. I might have one. So, yeah.
I have one question.
Yeah, fire away. Let me stop the recording.
How do you figure out what the domain is when you're graphing